So, hello everyone again. This is lecture 2 part 1 of ray optics and optical instruments. In the previous lecture we started a discussion on the mirror equation. We will go on with that discussion only. I will just go on with the formulas which are very evident for the mirror equation. Then we will go on to the examples of mirror equation and then further discussion will be carried out. So, let us not waste any time. I am Sameer Lavankar. Let us begin our discussion. So, the course outline for you, we started with the introduction of this ray optics, what is this ray optics, why it is required, what are the different variations we occur in this. Then the second point, we are currently in the second one, that is reflection of light by spherical mirrors. So, basically we are just carrying out a part. So, basically there is a sphere, we are just either cutting it from this side or this side and a mirror is being made. Depending upon the variation in which we cut it, they are called as convex mirrors and concave mirrors. So, right now we are on the reflection of light only. So, for the complete ray optics concept you just need to understand the sign conventions very carefully. If you understand the sign conventions, 90% of the topic is done. Okay. So, let us move on to the mirror equation formula again and then we will carry on with the examples. Okay. So, the mirror equation is here. So, these all things are being explained in the last lecture only, and finally we occurred that the mirror equation is denoted by 1 by u plus 1 by v is equal to 1 by f. So, what is f here? F is nothing but the focal length. What is u here? U is the image distance. What is v here? What is v is the image distance, u is the object distance. Okay. So, this is known as a mirror equation. Please remember that the sign conventions are already been occurred when the complete concept was being conceptualized, but even if you put the sign conventions in your examples also, that will be more good. I will explain this whatever I am saying right now. So, and finally after we also understood the magnification concept, I will just iterate it again. So, the size of the image relative to the size of the object is another important quantity to consider. We now define linear magnification, which is denoted by small m here, is as the ratio of the height of the image h dash. So, let us say this is the height of the image which is denoted by h dash, and to the height of the object, we are denoting the height of the object as equal to small h. Therefore, the magnification is denoted or defined equal to h dash upon h, that is m is equal to h dash upon h. Okay. So, h and h dash will be taken as positive or negative in accordance with the accepted sign convention in triangles. Now, let us move on. So, we are just trying to find out a relation of magnification with the image distance and the object distance here. So, as you can see in the triangle, so there are two triangles been made here. These two triangles are, first is triangle A dash P dash B. So, it is A dash, B dash and P, that is this one, and the second one is your ABP. So, ABP is this. Let me use a different color so as to make it more clear. So, these are the two triangles for which the similarity is being occurred here. Therefore, here basically we can say that as these two triangles are both a right angle triangles, hence they are similar. Therefore, we can say that B dash A dash by BA. So, therefore, B dash A dash. So, this by this is equal to B dash P by BP. So, it is B dash P by BP this. Therefore, using this equations, what we know that B dash A, so B dash A is nothing but, so this is basically minus H. What is BA? BA is your H, therefore H minus H by H is equal to BP, B dash P. What is your B dash P? B dash P is nothing but minus V. Why it is minus V? Because it is in the opposite sign convention is opposite to the direction of incidence of light. Therefore, it is minus V upon BP. What is BP? BP is again minus U. Therefore, what we get is minus H by H is equal to minus V by U, where therefore, we will get it as magnification is equal to V by U. Hence, just ignore this for now. Okay. Therefore, magnification is nothing but V by U. Okay. So, we have derived here the mirror equation, and here the magnification formula for the case of real inverted images by a concave mirror. Therefore, magnification is nothing but the image distance upon object distance. Okay. Let us move on. So, with the proper use of sign convention, these are in fact valid for all the cases of reflection by a spherical mirror, concave or convex, whether the image formed is real or virtual. So, basically what they are trying to say is they are just trying to say that it does not depend that the mirror is either convex or concave, it does not depend on that part here, it only depends on this part, that the mirror equation is valid for both the cases. Okay, so that is only written here. Let us move on. Okay, so with the proper use of sign convention, these are in fact valid for all the cases of reflection by spherical mirror, concave or convex, whether the image formed is real or virtual. Okay, fine. Next, the figure below shows the ray diagrams of virtual image formed by concave or as well as convex mirror about derived equation valid for these cases. So basically, as it is saying that as far as you know the sign conventions, you can apply the magnification formula and the mirror equation for either convex mirror also, concave mirror also, because both are part of a spherical mirror only. Okay. So, this is the end of this. So, just basically what they are saying is, so in this mirror what is happening is, as you know, for a parallel light it will pass through the focus, so it is going through the focus here as you can see, and similarly the other light which is passing through P will make an angle I which is equal to angle of reflection, therefore it is going like this. So basically they are not, they both are parallel lines, but a little parallel lines, but as you can see they are diverging from each other, but if you go backwards then you can find a virtual image for it. Therefore, a virtual image is formed is in this sequence. So, this is a virtual image being formed here. Virtual image. Okay. For this sequence, what is happening is again, so parallel line diverging, and similarly for passing through the pole, angle I is equal to angle R here, and as you can see both are again forming a virtual image on the back side of the mirror. Therefore, this is a virtual image here. Okay, fine. Let us move on. So, now let us move on to the example. So, please look over very carefully, because these examples are very important, because this will only make you understand the sign conventions concept. Okay. So, an object is placed at 10 centimeters or at 5 centimeters. So, basically there are two questions which you need to consider here, in front of a concave mirror of radius of curvature 15 centimeter. That means let us keep on writing first everything. So, because everything, every image, every object and focal length is always opposite to the direction of the incidence of light, we measure every distance from the pole of the mirror, and because the incidence of light is always in the opposite direction of the measurement, therefore we always take focal length as negative. Here image distance is also negative. Now let us calculate the value of image distance using the mirror equation. Okay. So for the first sequence, as it is written, radius of curvature is given to you, that means capital R is given to you as 15 centimeters. That means the focal length will be nothing but negative, please make sure it is negative first of all, minus R by 2, hence it will be equal to minus 15 by 2, which is equal to minus 7.5 centimeters. So, okay, first thing has been calculated here. Next is, so what is the actual thing which you need to calculate? Find the position, nature and magnification of the image. So, basically what you need to find, either the image is real or virtual. Second thing is, it is ahead of the mirror or back of the mirror, and what is its height. If you know its height, you can find out the magnification. Okay. Fine. So, let us move on. So, next thing is, now for the first case scenario, we know that the image object is placed at distance of 10 centimeters. That means u is given to you as minus 10. Please make sure it is minus 10 centimeter. Why it is minus 10? Because we are measuring from the pole of the mirror, and because the direction of the incidence of light is opposite to the direction of the measurement from the pole, that is why the object distance is measured as negative 10 centimeters. Okay. So, now just mirror equation has to be followed. So, basically 1 by u plus 1 by v is equal to 1 by f. Therefore, 1 by v is equal to 1 by f minus 1 by u. Therefore, v is equal to multiplication of u and f upon u minus f. Quite evident. So, this is the image distance we will calculate. Now, just put the values here. So, u is equal to minus 10 for us, f is equal to minus 7.5 for us, u is equal to minus 10 for us, and minus f is equal to minus 7.5 for us. That means v is equal to nothing but plus 75 upon minus 10 plus 7.5. Therefore, on calculating this value you will get V as equal to minus 30 centimeters. You will get minus 30 centimeters. Why minus 30? Quite evident, as you can see 75 upon this will be minus 2.5 if I am not wrong, and 25 30 is a 2.5 30 is a 75. Therefore, as minus sign is there, therefore, we will get the answer as equal to minus 30. So, what is the meaning of this minus 30 centimeter? That means that let us say this is the pole of the mirror. Let us say where is F. So, let us say this is 7.5 centimeters, let us say this is F, and what is the image? Image is much more far here. So, what is the value of minus 30 says that the image is also formed at the same distance, at the same side of the mirror only. So, it is formed somewhere here. So, this is the distance of V, this is the distance of U here. Okay. Let us move on. Next is magnification. So, magnification is nothing but equal to minus V by U. Magnification is nothing but equal to minus V by U. Hence, what you will get is this will be equal to nothing but minus of minus 30 upon minus 10. Hence, minus 3 is obtained. What is the meaning of minus 3 here? Minus 3 basically means as negative values used. That means, if the image is on the above side, is on the top side of the principal axis, then the image is formed on the bottom side of the principal axis. And magnification 3 times means that the amount or the height of the image formed is 3 times the image of the is 3 times the height of the object. Okay. So, that thing is only written here. So, basically object distance is u minus 10. Using the mirror equation you will get V is equal to minus 30. The image is 30 centimeters from the mirror on the same side of the object. Quite evident, it is on the same side of the object. Next is magnification m, which is equal to minus V by u. Therefore, it is minus of minus 30 upon minus 10, which is equal to minus 3. Okay. Next is the image, the height is magnified, real and inverted. So, height is magnified, real and inverted, quite evident. Why it is magnified? Because the value of magnification is greater than 1. Why it is real? Because the sign convention or the sign which we got for image is the same as that of the object. And why it is inverted? It is inverted because the magnification has a negative sign. Okay. So, everything has been understood. Let us move on to the second point now. So, for second point, what they are saying is just the value of u is being changed to minus 5 centimeters. So, just keep on varying everything. So, this time as you can see that the value of V obtained is positive. We did not obtain the value of V as negative this time. So, what does it mean? That the image formed is virtual and it is on the back side of the mirror obtained. Okay. Let us move on. So, basically nothing, V is equal to 15 sorry, this will be V is equal to 15 centimeters here. It is nothing but sorry, this will be also 5. So, this will be divided by 2 basically. This will be divided by 2, hence it will be equal to 30 by 2, which will give you 15 centimeters. Sorry, my mistake. Okay. So, the image distance is equal to minus 5 centimeters. So, mirror equation is this value, hence you will get the value of V is equal to plus 30 centimeters this case. So, basically V is plus, V is equal to plus 15 centimeters. Okay, fine. So, the image is formed at 15 centimeters behind the mirror. Why it is behind the mirror? Because the sign convention gives you the value of plus. If plus is given, that means that the direction of the measurement of the image is in the same direction as the direction of the incidence of light. If it is same as the direction of incidence of light is in this direction, therefore you will measure the distance from the P in this direction only. Therefore, you will get the value behind the mirror. Okay. Hence it is a virtual image, quite evident. Now, magnification that was minus V by u. So, therefore, minus V by u, minus of 15 by minus 3. Here as you can see that the magnification is first of all greater than 1, that means the value, that means the image is magnified. But the magnification has a sign convention of plus, that means the image formed is erect. That means if the height is in this direction, then the image is also in this direction only. In the previous sequence what was happening is that if the height is in this direction, the image was formed in this direction, that was the only change. So, this is inverted and this is erect, this is erect. Okay. Let us move on to the next case now. So, next question is that suppose while sitting in a parked car, you notice a jogger approaching towards you in the side view mirror of r is equal to 2 meters. So, what does it try to say is, let us suppose this is your rear view mirror and this is along a pathway. Let us suppose this is the complete pathway. Let us suppose this is the complete pathway, you are trying to see a jogger and let us say the jogger is here for now and it is moving towards you. The speed of the jogger is given to you, that means it is moving at a speed of 5 meter per second for now. How fast the image of the jogger appears to move when the jogger is at 39 meters, 29 meters, 19 meters and 9 meters away. So, you just need to calculate. So, this is basically a concept which you need to understand, that what happens to the relative speed of movement as the object gets nearer to the mirror. Does it get fastened up or does it get slowed down? Just we need to understand that concept here. Okay. So, quite evident, you just need to understand for each of these, so you can understand the static cases only and then you can understand what is happening by changing the rate of change of everything. Okay. So, first of all, from the mirror equation we obtain that V is equal to Fu upon U minus F. This is the same thing which is obtained here. So, this is nothing but this only, Fu upon U minus F. Okay. So, from convex mirror, as the mirror is convex here. So, first of all, whatever thing is given, let me write it here. So, first of all, r is given to you as 2 meters, f will be equal to r by 2 which is equal to 1 meters. Then next thing is u is given to you as minus 39 meters. Okay. So, as you can see here that it was a concave mirror, hence the focal length was negative 7.5 centimeters. As it is a convex mirror here, the focal length will be plus 1 centimeters. Okay, fine. So, just iterate inputting everything here. So, you will get V is equal to F into U. So, basically minus 39 into 1 upon U minus F. So, U minus F will give you minus 39 minus 1. Therefore, it will be 39 by 40 meters. So, basically that is the image distance when the object is at minus 39 meters. Minus 39 meter as in behind 39 meters from the pole of the mirror. Okay. Next is, when the jogger moves at a constant speed of 5 meter per second, after 1 second the position of the image V will be minus 39 plus 5, quite evident, that will be equal to minus 34. Therefore, as it is again same thing, you can just input the value of minus 39 to 34 and you will get that value equal to nothing but 34 by 35. Now, you know the distance. What is the speed? Speed is nothing but the rate of change of distance. Therefore, you can just subtract both of them. Per unit time is 1 second only, therefore, it will 39 by 40 minus 34 by 35, hence you will get the speed equal to 1 by 280 meters. So, at 39 meters you will get the speed equal to 1 by 280 meters. Fine. Next thing is, for next concept, that is therefore, the average speed of the image when the jogger is between 39 and 34 meters will be 1 by 280 meter per second. Now, similarly, it means u is equal to 29 meters. Now, let us move on to this portion here. So, as you move on, as you just keep on putting the data here, you will find that the speed of movement is changing, as you can see 1 by 150, 1 by 60, 1 by 10. So, what can you infer from these all data? 1 by 280, 1 by 150, 1 by 60 and 1 by 10. You can see that the speed is keep on increasing as the jogger is moving towards the mirror. So, that is the only conclusion of this example. So, let me conclude it. So, although the jogger has been moving at a constant speed, the speed of his or her image appears to increase substantially as he or she moves closer to the mirror. The phenomena can be noticed by any person sitting in a stationary car or a bus. In case of moving vehicles, the similar phenomena could be observed if the vehicle in the rear is moving closer with a constant speed. That means the mirror, this case moving vehicle, they are just saying that let us suppose that the moving vehicle in which you are sitting is, let us say, at 10 meter per second, and the car which is at your back is moving at a speed anything which is greater than 10 meter per second. Then you can again observe this phenomena. Okay. So, these are the just two examples which I need to give you the information about mirror equation. Let me stop it here. In the next lecture I will start with refraction concept. So, basically what is refraction, what is total internal reflection, what are the lens equations and so on will be explained in the subsequent discussions. So, let me stop it here only. Thank you so much.